have a fun problem tonight for you where we're actually trying to determine the product of x and y, where x and y represent the x and y coordinates of where the graph of the line and the circle intersect. It's down here and also up here. Now, first of all, what I want to do is just talk about estimates. Okay, and from the graph, I just want to do an estimate, and then we'll see how close our estimate is to the exact answer. So we want to do an estimate. Okay. Now, y'all, over here, by the way, if you don't believe this is a circle, 0, 7 is certainly the top point on the circle, because if you put x equals 0, 7 squared is 49, and of course 0, 3 is the y-intercept of the line. So you're believing that this is the line and this is the circle corresponding to the two equations. Now what I did is just did an eyeball job on this. Here's x and y intersection point in quadrant 2, and I just estimated minus 13/4. Okay, because it's a little bit to the left of x equals -3. In a similar fashion, the y-coordinate is a little bit above the value of 6. You see, it's to the left of -3 here, but it's above 6 right here. So that's why I chose minus 13/4, comma 25/4. Now the product here is easy to multiply out. 13 times 25 is minus 325, and this number is less than -20. Since 320 divided by 16 is 20. Now notice right down here, the symmetry here, it's kind of cool here. There's two intersection points, one down here also. Okay, now notice just by symmetry, the coordinates here have to just flip-flop basically. So you'll have 25/4 here is your x-coordinate, and then minus 13/4. If we're going to trust those estimates up there, we got to trust that these would be the estimates down here. Okay, but in both cases, their product will be the same, which is kind of interesting, I thought. Okay, so like that. Okay, and again with the very same estimate. Okay, so we get an estimate that's somewhere around -20. Now let's go down and just check out the math here. Now this is the original problem right here. And so this is fairly routine. If x plus 3 is equal to 3, if x plus y is equal to 3, then x plus y squared is equal to 9. But x plus y squared is also equal to x squared plus 2xy plus y squared. Now notice right here, something very convenient happens here. This tells us that 9 has to equal to, notice that x squared plus y squared is given to be 49. So 9 has to equal to 49 plus 2xy. Okay, and then pretty quickly from here, we see that if we subtract 49 from both sides, we get minus 40 here. So we have minus 40 equals to 2xy. Then after that, if you divide by 2, you get the product of x and y is -20. Okay, now notice we never actually even found the x and y coordinates, and they're not nice numbers. I think they're irrational numbers. But we never found the individual values of x and y, and yet we got this -20, which is fairly close. Let me get that circled. Notice that that's very close to our relatively crude estimates right here. When we made these estimates right here and did the product, we got it was less than -20. That would count for this intersection point too. So again, I thought it was kind of a neat little problem. We never ever determined the values of x and y. We started with graphical estimates, and then we actually got, with some fairly straightforward algebra, that the product of the x and y coordinates where the graph intersects is -20.